Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 7th, 2025, so just about 4 days ago. The big takeaway from this paper is a new framework for adapting powerful vision language models, which are AI systems that understand both images and text, to new tasks without needing any labeled data. The paper is titled, Adapting Vision Language Models Without Labels, a Comprehensive Survey, and its proposed taxonomy provides a much-needed roadmap for this rapidly evolving area of research. Essentially, it organizes the entire field based on how much unlabeled data is available for a given task, from having no data at all to having a continuous stream of it. Also, the authors shared their GitHub repository for this survey, and it's a fantastic resource. Rather than code, you'll find a massive, curated list of research papers on unsupervised and label-free methods for VLMs. It's a great starting point for anyone interested in this specific research area. Okay, and this diagram really lays out that taxonomy visually. At the center, you have the pre-trained vision language models, which are the starting point. The 4 adaptation methods then branch out, depending on the data available. On one side, you have data-free transfer, which uses only class names, and unsupervised domain transfer, which uses a large collection of unlabeled images. On the other side, we see methods for adapting during inference, like episodic test time adaptation for small batches, and online test time adaptation for a continuous data stream. Alright, and this chart breaks down those 4 paradigms even further, detailing the specific strategies used in each. For instance, with unsupervised domain transfer, where you have lots of data, methods include self-training, which is where the model creates its own labels to learn from. On the other end, for online test time adaptation with streaming data, the strategies involve things like pseudo-labeling, and using memory mechanisms to keep track of what the model has seen before. This provides a really clear map of the specific techniques. So let's zoom in on that first paradigm, data-free transfer, which is where the model adapts using only text. This figure shows 3 key strategies for doing that. First, with text augmentation, a large language model expands simple class names into richer descriptions to give the text encoder more to work with. Then there's image utilization, which uses those class names to find or generate a few relevant images from external sources. And finally, network modification involves directly changing the model's internal architecture to better suit the new task. This table then details some of the key research papers associated with those 3 strategies we just saw. For the text augmentation strategy, representative works include dclip and CUPL, which often use large language models to generate richer descriptions. When it comes to image utilization, you can see methods like RICO and priming. And finally, for network modification, the table points to research such as maskclip and sclip. It's a very helpful reference for anyone wanting to dive into the specific literature for these approaches. To evaluate these different approaches, researchers rely on a huge range of benchmarks, and this table provides a great overview. It covers everything from standard object classification using datasets like ImageNet to more complex challenges like semantic segmentation and even specialized domains such as medical image diagnosis. The columns on the right are particularly interesting. They show the popularity of each dataset for the 4 different adaptation paradigms we've been discussing, which is a really useful guide for understanding the current research landscape. Wrapping up, this survey provides a fantastic roadmap for adapting vision language models without labeled data. The key takeaway is its clear taxonomy, which organizes the field based on data availability from no data at all to a continuous stream. This framework really helps make sense of this rapidly evolving area. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.